Now, in this video, we are going to take up the problems on cantilever beam. And here, we are going to take up the problem number 1. A cantilever beam of length 2 meters carries a point loads as shown in the figure. Find the reactions at the fixed end and draw the shear force and bending moment diagram for the cantilever beam. So here, since it is a cantilever beam, one end of the beam is fixed and the other end is free. And the loads are acting at B by 2500 Newton downwards, and at C it is 2000 Newton, at D it is 1500 Newton, and at E 1000 Newton. All are acting downwards, and 2500 is acting at a distance of 0.5, and 2000 is acting at a distance of 1 meters, and 1500 is acting at a distance of 1.5 meters, and 1000 is acting at a distance of 2 meters from the end A. So since all the loads are acting downwards, the beam tends to bend in the downward direction. In order to keep the beam in the equilibrium condition, so we need to have a reactive moment which is acting in a counterclockwise direction. When it is acting downwards, it will going to be the beam will try to rotate in the clockwise. So in order to keep the equilibrium condition, so the beam will be in the counterclockwise direction, which is MA. So what are the reactions of the support you will going to get? The reactions of the supports are, as the load is acting downwards, all the loads, so reaction at the point A will be acting upwards, which is RAV. And then we need to know the horizontal reaction RAH and the reactive moment MA. So these are the three reactions which will going to be find out at the fixed end point A. So now we will going to consider that. So first one is sum of the horizontal forces acting on the beam will be equal to 0. So that means sigma h is equal to 0. But when you're considering the load which is carrying on the cantilever beam, here all the loads is acting downwards and there is no horizontal load which is acting on the beam. So sigma h will be equal to 0. So RAH will be equal to 0. As there is no horizontal load on the beam, so therefore RAH will be equal to 0. Now the next condition is we want to consider sum of all the vertical forces is acting on the beam. So as we know, all the loads are acting downwards. So in order to keep the beam in equilibrium condition, we have to have a reaction which is acting upward on the fixed end A in the vertical direction. So what will going to be the value of RAV? We need to sound out. So the condition is sum of all the vertical forces which is acting on the beam should be equal to 0. That is sigma V is equal to 0. So the convention what we follow is the load which is acting upwards is considered to be positive. So since the reaction at the point A in the vertical reaction is acting upwards because all the loads are acting downwards on the beam which is being as shown. Therefore, RAV which is acting upwards is positive minus 2500 minus 2000 minus 1500 minus 1000. So the summation of all these things should be equal to 0. So on simplification, we will going to get the value of RAV as 7000 Newton, which is acting upwards, which is a positive value. So we know that the reaction acting upwards is the load acting upwards is positive. So since RAV is positive, so therefore the load which is acting upwards is positive here. Therefore, RAV will be equal to 7000 Newton. Now we need to find out the reactive couple or the reactive moment which is acting in a counterclockwise direction. So the summation of all the moments which is acting on the beam will be equal to 0. So taking the moments about the point A, so here, so since the reactive moment is in the counterclockwise direction, but the sign convention what we follow, the clockwise direction is positive. Since MA is reacting in counterclockwise direction, so therefore minus MA plus. So all these loads are acting downwards, so it will tend to have a moment in the clockwise. So 2500 into 0.5 plus 2000 into 1 plus 1500 into 1.5 plus 1000 into 2. So adding up all these things, it will be equal to 0. Adding up all these things, you are going to get the reactive couple, MA, will be 7,500 Newton meter. So since it is a reactive couple, which will going to be in the counterclockwise direction. So this is how you will be able to find the reactive moment. Now we go for the shear force and bending moment. So let us consider a beam which has been given with all the loads which is acting on the beam. So now we want to find out what will going to be the shear force and bending moment at each of these points. So to do that, first we're going to consider the portion ED. So at any distance x from the free end, that is xx between E and D. So that means we are considering the portion between D and E now. So when we are considering the portion, we are considering at a distance, any distance x from the free end. So that means we are considering a section at any distance between D and E, which is at a distance of x from the free end E and D. Then Fx. So to the section which is acting to the right side downward direction is positive. So when you are considering the sign convention, if you are considering the section and if you are considering the section and it is acting towards the right side in the downward direction, it will going to be the positive value. So Fx will be equal to plus 1000 Newton constant. So here, so when you plot that, you can see Fx at E will going to be 1000 Newton. So between FED, the shear force between D and E, as there is no other load is acting between D and E, so naturally it remains constant. So you will going to get, which is between D and E, it will going to remain the same, which is 1000 Newton. Now, what will going to be the bending moment at the section XX? So when you are considering, suppose if you are considering the section here, and then the distance x from the free end. So what is the bending moment at this section? So force into the perpendicular distance, or the load into perpendicular distance, 1000 into x. So since it is a hogging bending moment, so it will going to be the negative. So mx will be equal to minus 1000 into x. Since the power of x is 1, therefore you will going to get the bending moment diagram, the line joining between the 2 points will going to be a linear line. So when the value of x is equal to 0, what happens? When the value of x is equal to 0, so we're going to get the bending moment at the point E. So which will going to be minus 1000 into 0, it becomes 0. So bending moment at the point E will be equal to 0. So that is what we will going to get. The bending moment at this point will going to be 0, and which is negative. So now similarly, when the value of x is equal to 0.5 meters, so what happens? The bending moment at the point D we will going to get, which will going to be, substitute the value of x as 0.5. So minus 1000 into 0.5, which will going to be minus 500 Newton meter. So this is what the bending moment at the point D we will going to get. Now, once you are considering this, now we will going to take the portion between D and C. When you are considering the portion between D and C, now you take the section between at any distance x from any distance x from the free end, that is xx between C and D. When you are considering the section between C and D, so what happens? So between C and D, when you are taking the section and that distance is x from the free end E. So what happens to the distance? Now what will going to be the Fx? Fx will going to be, so since you are considering the section between C and D, to the right acting downward direction is positive. So what will going to be the Fx? Fx will be plus 1000 plus 1500, which will going to be plus 2500 Newton. So now at the point D will going to be, it is FCD. Between FCD, it will going to remain constant, because as the load, there is no load as there is no other load which is acting between C and D at any part of the section between C and D, the load will going to remain the same, which will going to be 2500 Newton, which is a constant. So when you plot this, you can see the SF at the point D will going to be 2500, and between when x is equal to 0.5, it will going to be shear force at the point D which will going to be 2500. Between C and D, it remains constant as there is no other load which is acting between C and D. So Fx shear force at the point C will also be equal to 2500. Now, between C and D, it will going to be 2500. So what will going to be the bending moment when you are considering the bending moment at the section XX? What is mx? So when you are considering the section between C and D, which is at a distance of x from the free end, so mx will be equal to minus 1000 into x, because the beam tries to bend in the downward direction. So naturally it is hogging. So minus 1000 into x. Then as we know, the distance between xx to E is x. So what will going to be the distance between xx to D? Then it will be x minus 0.5. Then this distance will be going to be between the distance from xx to D will going to be x minus 0.5. So therefore, minus 1500 into x minus 0.5. So now we will going to put the value of x now. When the value of x is equal to 0.5, so what will going to be the bending moment? The bending moment at the point D, which is MD, which will be substitute the value of x as 0.5. So minus 1000 into x is 0.5. Minus 1500 into 0.5 minus 0.5 becomes 0. So that will be equal to minus 500 Newton meter. Now when the value of x is at 0.5, when the value of x is equal to 1, so what happens? Bending moment at the point C. So Bm at C will be equal to minus 1000 into 1 minus 1500 into 1 minus 0.5. Put the value of x is equal to 1 here. So it will going to be minus 1750. So when you plot this, you will going to get both are linear because the power of x is equal to 1. So Bm at 0 is 0. Bm at E is 0. Bm at D is minus 500 Newton meter. So which is given in this. And Bm at C will be minus 1750 Newton meter. Now we will going to consider the portion between C and B. So when you are considering the portion between C and B, so now what happens? We will going to take at any distance x from the free end, that is xx between C and B and C. But the distance of the section is with respect to E. So it is from x from E. So then what happens? So here between B and C, when you take the section, and when you are considering the section to the right of the section, the load acting downwards is positive by sign convention. So what will going to be Fx? Fx will be equal to plus 2000 plus 1000 plus 1500 plus 2000. So summing up of all these things, which will going to give you 4500. So FBC, as there is no other load, SF at C will going to be 4500. As there is no other load is acting between B and C, it will going to remain the constant of 4500 Newton. So this is how we will going to plot. When you are considering at SF at C, it will going to be 4500. Between B and C, it will going to remain the constant. It is 4500 positive. Now, when you are considering the bending moment at the section XX, so what happens when you are considering the bending moment at a section XX, which is at a distance of x from the free end? So from between B and C, the section XX is at a distance of x from the free end E. So then what happens to the distance between section XX? So what will going to be the bending moment at the point XX? Mx will be equal to minus 1000 into x. Then distance between xx to D will be x minus 0.5. So minus 1500 into x minus 0.5. And the distance between xx to C will going to be x minus 1. So then it will be minus 2000 into x minus 1. The sum of these moments will be equal to 0. Now, so since all the power of x is 1, so the line joining between the bending moments will going to be the linear. Now when the value of x is equal to 1, so what happens? Substitute the value of x as 1, which is Bm at C, which will be minus 1000 into 1, minus 1500 into 1 minus 0.5, minus 2000 into 1 minus 1, it becomes 0. So that will be equal to, on simplification, you will going to get it as minus 1750 meters. Similarly, when the value of x is 1.5, so BM at B will be equal to minus 1000 into 1.5 minus 1500 into 1.5 minus 0.5 minus 2000 into 1.5 minus 1, which will be equal to minus 4000 Newton meter. So here you will going to get the bending moment at the point C will be 1750 and the bending moment at the point B is 4000 Newton meter. Join these two points by means of a line which is a linear line because the power of x is 1. Now we will going to consider the portion between AB or BA. When you are considering that, so at any distance x from the free end, that is xx between B and A. Now when you are considering the distance between xx and B and A, so now it will going to be the entire cross section what we are considering. So considering at any distance x from the free end E. So what will going to be the shear force? SF at Fx. So considering the section to the right acting downwards is positive by sign convention. So which will going to be plus 2000 plus 1500 plus 2000 plus 2500. Summing up of all these things which will going to give you 7000 Newton, which is a constant value. So between B and A or FAB, as there is no other load is acting, therefore it remains same or constant, which is 7000 Newton. Now we are considering, so this is how, at the point B, which will going to be 7000, between A and B, it remains constant, which is 7000 Newton only, because as there is no other load acting between A and B. Now we will going to consider the bending moment at section XX. So what will going to be mx? So the distance is, now we are considering, first the load is 1000 into the distance between xx to the point E, which is x. So minus 1000 into x. Then the distance between the section xx to D, then it will be x minus 0.5. So that will be minus 1500 into x minus 0.5. Similarly, at section between xx and C, which will be minus 2000 into x minus 1. Similarly, distance of xx to B, so which will going to be x minus 1.5, that is minus 2500 into x minus 1.5. So that will be equal to, again, since the power of x is 1, it will going to be a linear curve. Then when you are considering the value of x as 1.5, what should be the value you should get? So substitute the value of x as 1.5, that will going to be the bending moment at the point B, which is MB, will be equal to minus 1000 into 1.5 minus 1500 into 1.5 minus 0.5 minus 2000 into 1.5 minus 1 minus 2500 into 1.5 minus 1.5, it becomes 0. So minus 0, which will be equal to, on simplification, you will going to get it as minus 4000 Newton meter. So similarly, when the value of x is equal to 2, if you are considering BM at the point A, BM at the point A will be equal to minus 2000 into 2 minus 2500 into 2 minus 0.5 minus 2000 into 2 minus 1 minus 2500 into 2 minus 1.5, which will be equal to minus 7500 Newton meter. So this will going to be the value of 7500 Newton meter. As we are, since the power of x is 1, so joining between this 4000 Newton meter to 7500 meter by means of a linear line. So this is how you will be able to analyze and solve the reaction moment, and also the shear, analyze and write the shear force diagram, and also the bending moment diagram for a cantilever beam applied with several loads which is acting downwards. Thank you.